Hi, I'm Greg Zott. I'm with the UCSF Diabetes Center in the Bluestone Laboratory, and today I'm going to show you the process for isolating mouse islets. The procedure involves the injection of a collagenase solution into the pancreas of a C3H donor mouse, where we will then remove that pancreas, digest it away, purify the islets on a phycol gradient, and then hand-pick them for ultimate transplant into the kidney capsule of a diabetic NOD mouse, which will be our recipient. Before we start this procedure, we diluted our collagenase solution in a modified Hanks buffer. And we have adjusted the concentration specific for the strain of mouse that we're using. The C3H we found digests better at a 0.8 mg per ml collagenase solution, and we will use that to inject into the common bile duct to distend the pancreas. Performing the procedure today will be Pavel Kudria of the Diabetes Center. He will open up the mouse, expose the intestines, and then inject into the common bile duct. We will spray down the mouse with ethanol to keep the hair down, and then we will also verify that the mouse has been sacrificed properly with a toe pinch. Pavel will now open up the mouse and exposing the intestine and the pancreas with a midline incision. The diaphragm will also be cut to verify that the mouse will be sacrificed. Before we get started, I'd like to point out some of the important structures. The stomach is lying right here with the pancreas attached underneath into the duodenum. And above this is the liver, where we'll find the gallbladder and the common bile duct, which you can see right here. So what Pavel will do next is he will isolate the small intestine, find where the common bile duct enters the small intestine. Once the intestine is exposed, we clamp on either side of the common bile duct with mosquito clamps. We find that this allows more collagenase to enter the pancreas, while other groups try to direct the clamp on top of the common bile duct. We find that this is a better technique in allowing enzyme to enter the pancreas. This is a gentle procedure. You don't want to tear the bowel. You want to allow the clamps to lie gently on either side of the common bile duct. Now we will find the gallbladder, and once the gallbladder is exposed, we will use that as a guide to injecting the collagenase into the common bile duct. Pavel's using a 30-gauge needle with a 5 cc syringe containing 3 ml of collagenase solution. As he's entering the common bile duct, he's distending that duct with collagenase solution. And then he travels down the common bile duct until he reaches near the intestine. And as he's going down, the enzyme solution is being pumped injected into the pancreas. Now that the pancreas is inflated with collagenase solution, Powell's going to remove the hemostats and then remove the pancreas from the mouse, carefully tearing it away from the intestine. He removes it from the stomach. And then using the spleen as a handle, he lifts up the pancreas and then slowly snips it away in the common bile duct. And that's it. Pancreas is laid out. And then the spleen is removed. And there, he's removing the mesenteric tissue. And then the pancreas is placed in a 2 ml collagenase solution in a sterilized glass vial. And then it's placed back on ice. The isolated pancreas that we put into the glass vials will now be placed into a 37-degree water bath for approximately 17 minutes. We place them into a 50 ml conical rack so that they don't float up. Once they're in the bath, the timer starts and the digestion begins. Once the digestion time is completed, the vials are removed and then they are shaken and disrupted gently. And once the tissue starts falling apart, the vial is then placed on ice. A sterile screen is placed over a 400 ml beaker that contains washing buffer. The pancreas digest is then carefully poured over the screen into the wash buffer. For demonstration purposes, the hood has been turned off and the glass of the hood has been raised so you could see what we're doing. Once the pancreas digest is poured into the beaker, the vials are rinsed with the same washing buffer and the wash buffer placed over the screen. We have a syringe filled with washing buffer. We will use that to forcefully wash the tissue through the screen. The idea is to release any loose islets that are unattached to the matrix, but leaving the membranes and the undigested tissue on the screen. And when you're finished washing the tissue, this is what you usually see at the end of the procedure. The pancreas tissue that's in the bottom of the tube will now be transferred to two 50 ml conicals and the tissue will be washed. The tissue's mixed evenly and then distributed evenly so that we have an equal pellet volume in each tube. The beaker is now rinsed with more washing buffer. The sides are rinsed so that you get all tissue that has entered the beaker. Again, then it's equally distributed between each tube. Both 50 ml conicals then are topped off with wash buffer. The tissue is inverted several times and then placed into a centrifuge. This is a quick spin. The centrifuge is allowed to reach 1,000 RPM, and then it's turned off. The tissue at this time is islets are very sensitive, and you don't want to overcompact them. The tubes are removed, and we will do this wash step 3 more times. This is the end of the third wash. The components of the 50 mil conical tube are transferred to the 15 conical tube and centrifuged for 1,000 RPM and then stopped. The supernatant will be removed, and the first part of the phycol will be started. We're at the step where we have our pelleted pancreas digest. We'll resuspend that tissue so it's nice and loose. To the pellets, we will add the first density gradient, which is 1108. We'll add 5 mils to each tube. The pellet is then mixed thoroughly in each of the gradients. It's important that you get good tissue distribution in your heaviest gradient. Now, we will layer 2 mils of 1096 density. We will then, on top of that, layer 2 mils of 1069 density, and then on top of that, 1037 density. It's important while you're layering the densities that you don't mix them. All the layers have been added to the tube, and you can see this is the top of 1108, the top of 1096, the top of 1069, and the top of 1037. And you can see the tissue is already starting to move to its proper density, even without centrifuging. The phycol gradients are brought up to speed at 1800 RPM for 15 minutes. And remember to keep the brake off. After the tubes are removed from the centrifuge, you can see between the 0096 and 007 layer, there's a nice band of islet tissue. Pavel is now removing the 037 layer to remove any tissue debris and DNA that might have been released during the processing. Using a sterile plastic pasture pipette, he will now remove the islet layer and transfer them to a 50 mil conical containing 25 mils of wash buffer. You want to do this step quickly because phycol is toxic to islets. We actually removed the entire 069 and 096 layer. Pavel cuts the top of the plastic pasture pipette and rinses it with wash buffer. The islets are then centrifuged like we centrifuged previously. The centrifuge is brought up to 1,000 RPM, and then we stop it. And we aspirate off the supernatant. Islets will be washed 3 times with wash media. So we just completed the islet isolation process. We took from the digest to the phycol gradient to the purified islets. After our third wash with wash buffer, we resuspended the islets in our RPMI media and we plated in a tissue culture plate. These islets are now ready for in vitro assays or in vivo preps like islet transplant.